So basically up until this point, right, you should have learned, or rather you should have been dealing with angles that are acute, right? Consider theta. Theta in this case is acute because it's between 0 and 90 degrees, right? But in reality, when we deal with the Cartesian plane, so consider this Cartesian plane over here, the y-x plane. This is an acute angle, right? Theta is an acute angle in this case. But it can also be a case where, theta, it can also be a case where theta is not acute, or rather it's obtuse, as you can see over here. Theta can be the red version, right? Or in fact, theta can also be reflex in the green version. So in both cases where theta is obtuse and reflex, how do we find the tuakaso of these angles, right? If it's acute, then it's rather straightforward because you can easily identify the opposite, the hypotenuse, and the adjacent side. But for obtuse and reflex angles, it's not that straightforward, isn't it? That's where we bring in the concept of ASTC. So before we begin, let me just label this quadrant. So looking at this Cartesian plane, in math we call this quadrant 1. Okay, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's the first concept you need to know. So I'll write over here, quadrants. The next concept you need to know is something called positive and negative angles. So if the angle, all angles will start on this line over here. Okay, this is where all the angles will start. That's our reference point. If the angle theta goes in a anti-clockwise direction, so in this direction, we call this the positive angle. Okay, but if theta goes in the other direction, the clockwise direction, then we'll call this the negative angle. So these are the differences. So in this case, for the red one, it will be the positive angle, and in the other case, theta will be negative. So for example, assuming this one is 240 degrees, right? So theta will be 240, theta will be, let's say, 130 degrees. And in this case, on the below one, we'll call this theta equals to negative 130 degrees. You just put the negative sign there. So that is the second concept you need to know, which is the positive and the negative angles. So now on to the the main part of this thing. Let's say we have a obtuse angle theta over here, right? How do we quantify what is the sine, cosine, tangent of this angle, right? Because we can't do it directly like that. It's not an acute angle. That's where we'll bring in this concept called the basic angle. So the basic angle is basically this red angle over here, and we will label it as such. Some of you may call it the reference angle, some of you may call it the basic angle, but either way it's fine. Basically what this basic angle is the angle between the line, so the hypotenuse, and the x-axis. So in quadrant 1, okay, in quadrant 1, let's say this is theta, right? That means in quadrant 1, theta equals to the basic angle as well. The value is the same. Whereas in quadrant 2, theta equals to 180 minus basic angle. This is for quadrant 2. For quadrant 3, assuming theta comes all the way until here, in order to find what's the basic angle over here, we will just take 180 theta equals to 180 degrees plus basic angle. And then for the last quadrant over here, assuming this angle comes all the way until here, for quadrant 4, this is the basic angle because it's the angle between the hypotenuse and the axis, and we call this basic angle. So in quadrant 4, theta will equal to 360 degrees minus away the basic angle. So this is how to find the value of theta using basic angle. Alright, now that is the third concept, which is the using, or rather basic angle, and this is the notation for the basic angle. Now that being said, let's go on to the main concept of this. So okay, let me erase this. Now, as I said earlier, this is theta, this is the basic angle. So in order to find the, let's say in quadrant 2, right? Let's say in order to find the sine of theta in quadrant 2, we cannot directly use O over H, right? Because you wouldn't be able to tell. That's why in quadrant 2, we will use the basic angle as reference. We will reference to the basic angle. And that's where we will look at the tuakaso of the basic angle. So we'll use the basic angle because basic angle is always acute. So this basic angle is always acute. And that's why we will always reference to the basic angle and find the tuakaso of the basic angle. And then once we find the tuakaso of the basic angle, we will then reference that to the tuakaso of the theta in contention, which is this one. So in this case, this one will be the opposite, this one will be the adjacent, this will be the hypotenuse, right? And that's where the concept of the ASTC comes in. So ASTC, all of these are broken up into the quadrants. So this A refers to the first quadrant, Q1, this one refers to Q2, this one refers to Q3, this one refers to Q4, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And what this means is, for A, it stands for all positive. That means in quadrant 1, sine theta equals to sine basic angle. Cosine theta equals to cosine basic angle. Tangent theta equals to tangent basic angle. And then for S, it means that it's only sine positive. That means in quadrant 2, only sine will be positive and the rest will be negative. So sine theta in quadrant 2 equals to sine basic angle. Cosine theta equals to negative cosine basic angle. Tangent theta equals to negative tangent basic angle. And then the same thing goes on. So for quadrant 3, it will be only tangent is positive. Then for quadrant 4, it's only cosine positive. That means if I were to write out everything over here for you to see, it will look like that. So in this case, sine theta in quadrant 3 equals to negative sine basic angle. Cosine theta equals to negative cosine basic angle. Tangent theta equals to tangent basic angle. Then for the quadrant 4, it will be sine theta equals to negative sine basic angle. Cosine theta equals to cosine basic angle. And then tangent theta equals to negative tangent basic angle. So in order to find what is this, where if this is in quadrant 2, that means this theta will be obtuse, right? We will take reference to the basic angle over here. So we will find what is the tuakaso of the basic angle. And once we find the tuakaso of the basic angle, depending on which quadrant the theta lies in, whether it's quadrant 2, quadrant 3, or quadrant 4, then you will see whether it will be exactly the same as the sine theta, cosine theta, or tangent theta of the basic angle, or whether you need to put in the negative signs, as you can see over here. So how do you solve questions using ASTC? First and foremost, you find out your basic angle. And how do you find out the basic angle? I went through earlier. If it's quadrant 1, theta equals to basic angle. If it's quadrant 2, theta equals to 180 degrees minus basic angle, right? And then if it's quadrant 3, it will be 180 degrees plus basic angle. And then for quadrant 4, it will be 360 degrees minus basic angle. So you just manipulate this equation to find out what is your theta over here, right? And then this is your basic angle. And once you find out your basic angle, then you proceed to find out what is the tuakaso of your basic angle. And once you find out what's the tuakaso of your basic angle, depending on which quadrant it is, whether it's quadrant 1, 2, 3, or 4, then you will use the ASTC formula over here to figure out whether the sine, cosine, tangent of the theta equals to the positive or the negative of the basic angle. And that's exactly how you use the concept of ASTC in trigonometry. And the reason why we have ASTC is because theta can not only be acute, but it also can be obtuse and reflex. And if it's obtuse, it will fall inside quadrant 2. If it's reflex, it will fall inside quadrant 3, quadrant 4. If it's acute, it will fall inside quadrant 1 over here. And that's the entire concept over here. Now, just one more concept before we move on. Earlier on, I talked about positive angles and negative angles. Now, what if theta is in the if it's a negative angle? That means it moves the other direction. It's exactly the same. You can still use the ASTC formula. So this is ASTC. It doesn't matter, right? It's exactly the same. It's just that now your angle will be negative theta. So if it's, let's say, we have a negative angle in quadrant 4, right? This is your negative angle. That means if I were to erase this, it will be ASTC, right? So this is still quadrant 4, so C is still positive. That means what we will have is sine negative angle equals to negative sine theta. First, we convert everything first. Next, cosine negative angle equals to cosine theta. And then last one will be tangent negative angle equals to negative tangent theta. And then we solve accordingly, just like that. So this is the fundamental concepts of ASTC. And now let me show you how to apply all of this knowledge into your questions over here. So for question 1, given that we have two angles A and B, right? A and B lie in the same quadrant, but we don't know what this quadrant is. So later on we will need to find out. And sine A equals to negative 3 over 5 and tangent B equals to 2 over 5. So find cosine A and cosine B. So looking at this, sine A equals to negative 3 over 5, which is negative, right? Therefore, looking at this, ASTC, since sine is negative, means it cannot fall here, it cannot fall here. Because in quadrant 1, quadrant 2, it's positive. Therefore, A lies in either quadrant 3 or 4. This is the first step. The second step would be to repeat for tangent. Tangent B equals to 2 over 5. If tangent is positive, that means it can either be inside here or inside here, right? Since it's positive. And therefore, B lies in either quadrant 1 or 3. And since both angles lie in the same quadrant, we will take the common quadrant between these two. And therefore, A and B lies in quadrant 3. So if we were to draw it out for, let's say, angle A first. So this is your Cartesian plane. For this is your angle A. This is your Cartesian plane for angle B. Now for angle A, since it's sine equals to negative 3 over 5, right? This means that we know in quadrant 3, sine A equals to negative sine basic angle. That means sine basic angle equals to 3 over 5. So if we were to draw out, it will look like that. This is your basic angle. This is 3. This is 5. And this is your 90 degrees. Right? So in order to find the first question, which is what is cosine A? Cosine A is pretty much just A over H. So this is O, this is H. We need to find what is your A in the first place. So therefore, we will use Pythagoras theorem. By Pythagoras theorem, we will call this A. A squared plus 3 squared is 5 squared. And therefore, when you solve it, you will find out that A equals to 4. So over here, A is 4. And therefore, cosine A is just A over H, right? And then, which essentially is just 4 over 5. And now, since cosine A is in the third quadrant, we know that in the third quadrant, this is cosine basic angle. This is your cosine basic angle. We know that cosine big A equals to negative cosine basic angle. And therefore, the answer is negative 4 over 5. That is for cosine A. And then now you repeat this process for cosine B, right? We do this entire process for cosine B over here. So let me just carve out a space. This is cosine B. Y, X. Now, looking at cosine B, tangent B is 2 over 5. So this is ASTC. That means in this third quadrant over here, tangent B equals to tangent basic angle, which is 2 over 5. Because it's AST, T is positive. That means it will look like that. This is your basic angle. This is your 5, and then this is your 2. So this is your remaining left, and we'll call this R. So therefore, first thing to find R by Pythagoras theorem, we get that 2 squared plus 5 squared is R squared. So R squared is just 29. R is 29 squared. R is 29. And R is the positive value because R must be 0. Must be bigger than 0. And therefore, to find what is cosine B, we will just take cosine basic angle equals to 5 over square root 29. And cosine B in this case is negative cosine basic angle, which is negative 5 over square root 29. So this is the answer, where it's negative cosine basic angle, which is negative over 5 over square root 29. And that is the answer. Okay, for question 2, now consider this. You have cosine 40 degrees equals to A. Now express the following in terms of A. So for sine, part A is pretty straightforward. Sine 50 degrees. Okay, you just got to remember this formula, right? Cosine 90 minus this equals to sine this. Therefore, sine 50 degrees is just cosine 90 degrees minus 50 degrees is just cosine 40 degrees. Therefore, it's A. And then for B, now you want to find out what is this. So first thing first, the question give us in degrees. And now the question give us another form which is in radians. So the first thing we need to do is to convert it to degrees. So sine 11 9 pi equals to sine 11 over 9 times 180 degrees, which is sine 220 degrees. So now since it's 220 degrees, looking at the Cartesian plane, yx, we know that it will fall somewhere here. This is your base, your angle in contention, right? So 220 degrees lies in the third quadrant. And since it lies in the third quadrant, this is our basic angle over here. So to find out what's the basic angle, we just take 180. 220 degrees minus 180 degrees equals to 40 degrees. And therefore, we know that basic angle is 40 degrees. Therefore, sine 220 degrees. This is ASTC, right? So this is in the third quadrant. We know that sine theta equals to negative sine basic angle. So in this case, we will have sine 220 degrees equals to negative sine basic angle. And we know that the basic angle is 40, therefore it's sine 220 degrees equals to negative sine 40 degrees. And therefore, the answer is just this. If we now want to find out what is sine 40 degrees, we'll just need to look at this. So consider this graph over here again. Right? You have, okay, or rather consider this basic angle triangle over here. So this over here is 40 degrees. And now since cosine 40 degrees equals to a, right? That means it's a over 1. And therefore this is a, this is 1. So in order to find this, we just use Pythagoras theorem, which is square root 1 square minus a square, which is 1 minus a squared. And therefore, negative sine 40 degrees is just negative O over H, which is negative 1 minus a squared over 1. And it's negative 1 minus a squared. That's the answer. So this is how to solve ASTC questions. If you want more help and resources, you can go ahead and click the link in my bio under this video. And if you want access to all of these notes that I make and go through in all the videos, you also can find it in the link in the description under this video. And if you want more help with trigonometry, there's a video that will appear on the right over here right now. Go ahead and take a look at that. If not, thanks for watching. I will see you in the next video.